I would like to define what do you mean by surface tension. That's what our aim in this video is, explaining you the very meaning and the definition of surface tension. I have already tried to explain the meaning of the surface tension basing on the previous videos by saying something like, because of the surface tension, the free surface of a liquid behaves like a stretched elastic membrane. That's explained basing on molecular theory. Please refer the previous video to know how surface tension concept is explained basing on that molecular theory. Now I'm going to stick to the definition of the surface tension. So to define surface tension, first of all, being it's a property of a liquid, we shall have a liquid. So what are the basic things required for a surface tension liquid? And to that liquid, we need to have a free surface. Free surface means it's not attached to anything else, it's free, right? And that free surface shall be in equilibrium. Means there is no resultant force acting on that free surface, right? So you shall have a liquid. Of course, that liquid shall have a free surface that is in equilibrium, if that is the case. So let me just draw a diagram to explain what do I mean by that. Imagine a vessel. On that there is a liquid. The surface is a free surface because it is not having any kind of a resultant force acting on that. Now it's an equilibrium, right? I shall imagine a kind of a tangential force. So, how do you define surface tension? Let me first tell you the surface tension definition, then I'll explain, right? It's a surface tension is a tangential force per unit length. So, first, let me explain what do you mean by a tangential force? It is a force tangential to the surface of the liquid, free surface of the liquid. So, if you call this as a say surface of a liquid, if you imagine a kind of a line like my pen that I have on it, so this is the surface of the liquid. My palm is the surface of the free surface of the liquid. So the tangential force will be like this, tangential to the surface. It will be on the surface, right? Not only tangential to the free surface, it is on the either side of this imaginary line. So this black pen that what I am keeping on my path, imagine it like a line. On that imaginary line, there is a tangential force on the surface of the liquid, right? So assume my palm is the surface of the liquid now. On that, you imagine a kind of a line, black pen is the line. On that, there is a tangential force onto the surface of the liquid. This is the surface of the liquid. This is the surface of the liquid. On both the sides, there is a tangential force acting this way, away from the black pen. This way, this way, this way to on this side, away from the black pen, away from the imagined line. So that's the definition of a surface tension in a nutshell. So what's the conditions that we have kept? It shall be a tangential force per unit length. Where is this tangential force is? On either side of line. Where is line? This line is not actually there. It was imagined. We have imagined that line. And how is the tangential force is? Normal to that imaginary line. Normal to that imaginary line. So if this is the free surface, if this is the imagined line, this is all the free surface, this is all the surface of the liquid, and now this is the imagined line. So that surface tension force is the tangential force per unit length. Tangential means that's on the surface of the liquid, like I am drawing. Not only on the surface tangential, it is normal to the imagined line. All that conditions has to be satisfied, right? So on either side of the on the imagined line, normal to that of the line, if there is a force acting on the free surface of the liquid that is in equilibrium, that kind of a force could be called like a surface tension. Now, so I can write as a formula surface tension as the tangential force acting per unit length. I'm repeating the definition. A tangential force acting per unit length on the imagined line on the free surface of the liquid in equilibrium on either sides, and this force is normal to the surface, normal to the line that is imagined. That's how the surface tension is defined. So if you want to know what is its SI units is, force is measured in a unit Newton, length is measured in a unit meter, so its SI unit is Newton per meter, right? Or its CGS unit is force in CGS system is measured as dyne, length is measured in centimeter, so the other way of saying the unit is dyne per centimeter. So if you want to say, for example, convert the surface tension value from SI system to CGS system and vice versa, how do you convert that? I will just scroll up the page to write it, right? So I want to write about a conversion factor. Surface tension is defined as force per unit length. Its unit is Newton per meter in SI system. But if I want to convert, I know 1 Newton, say its value is some x, whose value is x Newton per meter. Surface tension is x. Newton can be converted. 1 Newton is equal to 10 power 5 dyne. This we have learned in units and dimensions. Please check the chapter if you are not sure of this. 1 meter is also equal to 100 centimeters. So the value of the surface tension will be in CG system x 10 power 5 by 100 is 10 square dyne per centimeter. So 10 power 3 by 10 power 5 by 10 power 2 is 10 power 3 dyne per centimeter, the same value of the x. So you can express surface tension in any of the system of the units basing on your requirement, and we can convert them from one system to other system, right? Now we can also write something called dimensional formula. Dimensional formula is the representation of a physical quantity in terms of fundamental quantities of SI system. So the definition of the surface tension is force per unit length. Force is mass into acceleration per unit length. Mass, acceleration can be velocity by time, change in velocity by time, and of course length. To simplify further, mass, velocity is displacement by time. I'm talking only about the dimensions. By time is there and by length is there. So this length and this length can be cancelled. So what's remaining is mass by time and time. So m power 1, there is no L power 0, time and time is there, t power minus 2. That's the dimensional formula of the surface tension. So in this video, in this small video, we have just learned about the definition of surface tension and how do we apply it in different cases we will discuss in my next video. Thank you. Thank you for watching.